Reactive oxygen species, better known as ROS, are the biochemical equivalent of that one overenthusiastic coworker who means well but keeps knocking things over and setting small fires. These molecules, including superoxide anions, O2, hydrogen peroxide, H2O2, and hydroxyl radicals, OH, are generated during normal cellular respiration and immune responses, especially in high-energy environments like the mitochondria and bloodstream. At low levels, ROS act as signaling molecules, helping to regulate processes like inflammation, vasodilation, and immune defense. But when their levels spike, or when the body's cleanup crew falls behind, ROS go from helpful to harmful, triggering a cascade of cellular aging, tissue damage, and degenerative disease. In the bloodstream, ROS are produced from multiple sources. The most prominent generator is the mitochondria of circulating cells, especially immune cells like neutrophils and macrophages. These cells create ROS on purpose during a process called the respiratory burst, a defensive maneuver designed to kill invading microbes. But the bloodstream also hosts other ROS-generating events, such as the oxidation of LDL cholesterol, iron overload reactions, halofenton chemistry, and the unintended side effects of chronic inflammation. Even environmental stressors like UV radiation, smoking, pollution, or a greasy cheeseburger can elevate circulating ROS through indirect metabolic stress. Once generated, ROS begin damaging whatever they can grab onto. These molecules are highly reactive and non-discriminating. They oxidize lipids in cell membranes, denature proteins, and break strands of DNA like a toddler with no nap. In the vascular system, ROS degrade the endothelium, the inner lining of blood vessels, leading to impaired nitric oxide signaling and stiffer, more injury-prone arteries. They also oxidize circulating lipoproteins like LDL, turning them into foam cell bait and setting the stage for atherosclerosis. Over time, this blood-borne damage can accelerate the aging of not just cells, but entire tissues and organs. ROS also play a dark role in the immune system's decline. Chronic oxidative stress impairs T-cell function, shortens telomeres, and disrupts the balance between inflammatory and regulatory immune responses. In the aging process, aka senescence, cells exposed to high ROS levels often enter a zombie-like state where they stop dividing but start secreting pro-inflammatory factors, the senescence-associated secretory phenotype, or SASP. These zombie cells contribute to inflammaging and recruit more damage, creating a feedback loop of molecular sabotage. But our bodies aren't helpless in this chemical storm. They've evolved an elegant internal defense network, a molecular SWAT team that includes enzymes like superoxide dismutase, SOD, catalase, and glutathione peroxidase. Among them, glutathione is the star. This tripeptide, made of glutamine, cysteine, and glycine, is found in nearly every cell and in plasma, where it neutralizes RLS by donating electrons, converting dangerous radicals into harmless water or other excretable forms. Glutathione is essentially the body's internal anti-rust coating, and its depletion is a hallmark of aging and oxidative stress. Another rising star in this redox regulation is the family of indole metabolites, particularly indole 3-propionic acid, IPA, which is produced by gut microbes and circulates in the blood. IPA is not only a powerful antioxidant in its own right, it also activates the aryl hydrocarbon receptor, AHR, modulating detoxification genes and dampening inflammatory responses. Unlike many antioxidants that get overwhelmed in high ROS conditions, IPA remains stable and continues to buffer oxidative insults without flipping into pro-oxidant mode. It's like a Zen master in a room full of caffeinated squirrels. The antioxidant defense doesn't stop there. Nutrients like vitamin C, ascorbate, and vitamin E, tocopherol, circulate in the blood as first-response antioxidants, mopping up ROS before they hit cell membranes or DNA. Enzymes like peroxidoxins and thioredoxins help maintain redox homeostasis at the molecular level, while NRF2, a transcription factor, activates genes responsible for antioxidant production and detoxification. Even lifestyle factors act like ROS regulators. Aerobic exercise, for example, creates a brief oxidative burst that upregulates antioxidant defenses. Think of it as a stress rehearsal that makes your body more resilient in the long run. On the other hand, chronic sleep deprivation, overnutrition, or uncontrolled blood sugar feed ROS production like a buffet. It's not just about antioxidants in your smoothie, it's about training your cellular fire department to stay alert without burning out. The real trick of aging gracefully isn't eliminating ROS entirely. That's impossible and, frankly, unwise. We need a bit of oxidative friction for normal physiology. The goal is to keep ROS at Goldilocks levels. Not too much, not too little, just enough to keep cells signaling, mitochondria humming, and immune cells responsive. It's a delicate, dynamic balance, one that the bloodstream reflects almost perfectly. So the next time you hear about oxidative stress as some vague villain, remember, ROS are just molecules trying to do their job. It's only when they go unsupervised that they become destructive. Thankfully, your blood carries not just the threat, but the solution. Molecule for molecule, it's a battleground, but one your body is remarkably good at navigating until age, environment, or lifestyle tips the balance.